Hello and welcome to this course on electromagnetism. And I'm basically going through Young and Freedman's University Physics. And let's go ahead and start with their first chapter on electromagnetism in that section. And this is very simple, nice and easy. If you're taking this course, you're probably way ahead of this lesson, but we got to start somewhere, right? So, lesson 21.1, electric charge. All right. So, what is electric charge? Well, there are these things called electromagnetic interactions. My nephew used to have this toy. I remember he would wind it up. It would point to these. You would wind it up, and it would point to these things. There was this one where it said electric sockets in the wall aren't fun at all. Okay, that's an electromagnetic interaction. Trying to teach a child not to put their finger in a socket. I wouldn't even suggest it because are they really going to think of it? Not important. Anyway, there are four basic known kinds of forces, or at least this is what we're saying these days. Electromagnetic interactions are one of four kinds of forces. The other ones are gravitation, which is it really a force? I mean, I don't know. If you fall over a plane, you do fall, you do go splat, probably. But anyway, gravitation, we'll go ahead and call it a force, shall we? Maybe it's the bending of space, but that's not important either. There are these other forces you may or may not heard of, the strong nuclear force. The idea here is that something we're going to see later in this video is that like charges repel. Bing! So if you've got these positive protons, they're called, in the atom, you probably have heard of them, and they're positively charged, and they're together in a little huddle inside the nucleus. Why don't they go boom? Why doesn't the nucleus of an atom go boom? Because you have all these protons that are similar charge, positive charge. And the answer that physicists give is the strong nuclear force. There is also a weak nuclear force, which has to do with radioactive decay. Anyway, one of the great discoveries of the late 20th century was that electromagnetic interactions, strong nuclear force, and weak nuclear force, that these are actually the same force in different flavors. That they have been unified. There are theories in physics that unify those three. That's way beyond what we're doing in this course, but actually in the 1800s, who was it? Good grief, my brain is fried. James Maxwell Clerk. All I had to do was pause the tape. Unified the magnetic force and the electric force, because in the early 1800s, they didn't know that these were different varieties of the same force. Anyway, four kinds of forces, the Fantastic Four, and one of them is the electromagnetic force, and that's what this Udemy course is about. So, if you rub fur on plastic, they will attract each other. If cold, dry day, you might have, I'm having a bad hair day. That's because your hair has become electrically charged. Rub silk on glass, they come to attract each other. These are electrical phenomena that are going on. But if you take two of these plastic rods or two of these glass rods, because they've now become of similar charge, they will repel each other. This is all electromagnetic stuff. All right, electric charge is what we say that the fur, the plastic, the glass, and the silk in this previous experiment, it's what they've acquired. They've acquired an electric charge, either positive or negative. Now, aside from gravitational forces, most of the forces we experience every day are the result of electric interactions. That is, the strong nuclear force is going on all the time. Weak nuclear force, it's out there. Gravity, I experience quite often, especially when I go, which I don't do very often, frankly, and thankfully. But most of the experiences, most of the forces we might hear an electrical force. But anyway, most of the forces that we observe in our day-to-day life is a result of electric interactions. So here's some basic rules. Let me get this in a drum roll. Now we're ready. Some basic rules. First of all, our first basic rule is that like charges repel, opposite charges attract. I've been saying that, but it's true. Two positives repel. Two negatives repel. Like charges repel. Now, opposite charges attract. Is that my third one? Nope. But yeah, it's in the first one. There. What are you looking at, Ken? Like charges repel, opposite charges attract. Okay, next one. The total charges in any closed system is constant. You know, you can spin it in different ways. You can have some here and some there, some here and some there, but the total charge in any closed system where, you know, there's no electricity coming in or going out, that's a closed system, total charges is going to remain constant. And the magnitude of the charge of an electron or proton is the basic unit of charge. So again, we're going to talk about atoms, I think, on the next slide, but basically in the early 20th century, it was discovered that the nucleus of an atom, the kind of the core of an atom, is positively charged and made up of something called protons, and each proton is a +1 charge. Outside the nucleus, initially they wondered if it was kind of like a solar system, you know, like electrons as planets going around. You've probably seen a diagram like that. That's not exactly right, but electrons are negatively charged, and one electron is a -1 charge. So proton +1, electron -1, and these are the basic units of electricity. Now, it's so small, those are so small that we have to come up with other units in our daily life, the amp, things like that, which are massive amounts of electrons and such. But in terms of if we could boil it all down to the most basic charge is the charge of an electron or proton. So atoms are the fundamental building blocks of everything that we can identify as distinct stuff. So, you know, you can break an atom up. We found this, unfortunately, in 1945, you know, when basically, actually, they knew it before then because they were getting ready for it. But in 1945, when Hiroshima and Nagasaki went boom, it was pretty clear that you can break an atom apart. But in terms of kind of distinct building blocks of stuff, of matter around us, atoms are the fundamental building blocks. The atom is made up of 3 basic particles. Again, the late 20th century, they just went overboard with, well, there's a gluon, you know, there's a muon, you know, there's a quark, you know, there's an up quark, a down quark, anyway, a strange quark. They went crazy in the late 20th century. It was all valuable, but basically in elementary school, we're going to say electrons, protons, neutrons. Electrons are the planets in the solar system, not really. Negative charged. Protons are the nucleus, positive charge. The nucleus also has these things called neutrons. They are neutral. You know, a neutron walks into the bar, you know, says, "How much, waiter?" The waiter says, "For you, no charge." Anyway, bom, bom. So a neutron has no charge. It's also in the nucleus. 3 basic particles in an atom. An atom is basically a very, very, very teeny small nucleus surrounded by lots of space where the electrons are. Other important items to finish up this video. Please stop talking, man. The number of protons in an atom tells you what it is. So like if it's carbon, if it's oxygen, if it's nitrogen, is it uranium? The number of protons is its atomic number. You know, hydrogen, atomic number 1 proton. Helium, atomic number 2 protons. Lithium, atomic number 3 protons. And we could just keep going across what's called the periodic table and see all these different elements that, how are they defined? By the number of protons in the nucleus. Now, in its normal or natural, well, in its normal state, in its neutral state, the number of protons and electrons is the same. Now, there are some atoms that like to get rid of those electrons, like hydrogen. Take my electron, please, take it away. I don't want it. Hydrogens like to get rid of their electrons. But in a resting state, I'll call it, a hydrogen has 1 proton and 1 electron. So in the normal state, the neutral state, the number of protons and electrons is equal, and you have a neutral charge, no charge. An atom can gain or lose electrons and then become what's called an ion. So when hydrogen loses an electron, it gets rid of some of its negativity. It becomes more positive, right? +1. Lithium is also an atom that likes to get rid of its outer electron and become +1 ion. And so ions are positively or negatively charged collections of atoms that have lost or gained electrons. We call this ionization. When I'm becoming an ion, I'm becoming charged. So when a kind of neutral atom becomes an ion and takes on a charge. That's called ionization. Oh, that's enough. I'm just over 10 minutes. Rats, just over 10 minutes. But that is our first lesson in electromagnetism. And this has been on Electric Charge, featured by Young and Freedman's University Physics.